Right, so here's the brass grounding plate. I've cleaned off all the oil and crumbs. Crumbs, I guess, amp crumbs. But you can see all the corrosion there. So we'll give it a hit with some Scotch-Brite and remove that solder and clean that area in the chassis in preparation for reinstallation. Well, there we go. Shiny. Blowing out the camera, just like it should. So let's get all this mess back together, eh? Alright, champions, it's Monday. Monday morning. I had to sort of leave this one over the weekend and just finish her off. We'll get into what I've done shortly, but we'll just go over a few extra issues. It's still got a few problems, so we'll run over them first, and then we'll address them, and then go over everything that we've done. So one of them is that the shorting contacts on the input jacks are fatigued. You can see someone's tried to bend it in the past, but that never really works unless you do it a certain way, which I can show you. So we'll see if we can address that. Otherwise we'll have to replace the jacks. The fuse was giving some intermittency, so I actually cleaned out all that oil stuff. It was the oil, it was like there was some kind of dielectric, and the contacts were a bit loose. Managed to retension them and just cleaned it out with alcohol, blasted it out with compressed air a few cycles, and now it's solid as a rock. Now I tried using these Tube Amp Doctor 6v6 GTSs. These were like summer of '69 valves. They advertised them, they were ex-Soviet, new old stock. I thought I'd give them a try because at the time availability was spotty on the other stuff, and I've had issues with their STR series, the red base 6v6s, just going short and running away after a while. You test them for a month, no problem, and then a month and 1 day they just fail for no reason. So I've got some JJ's double mica 6v6s on the way. They should get here today or tomorrow. In the meantime, I've just got some groove tubes in there that I just use for testing some known good valves. So with much difficulty, I pulled the reverb tank out. This degraded rubber used to damp the pan had stuck itself to the inside of the bag, so I had to get a ruler in there and sort of pry it apart in order to slide it out. I just removed it to inspect it, make sure the springs and everything are good, and I want to change the RCA connectors as well because I've got those shitty stock ones. Now this is a Hammond tank, and as soon as I plugged it in, we got a hum. As soon as I plugged the input in, the output was fine, but as soon as the input made connection with the ground, we got some ground loop hum. Now that's because this is not an isolated input jack. So, as the astute among you all know, a standard Fender, you know, AB763, AA1164, whatever, the standard reverb tank has an insulated input. So it's still got both terminals, obviously, because you've got to transfer, you know, power to the coil, but it's isolated from the pan. There's no connection from the ground to the pan itself, whereas on the output, it is shielded. It's direct connection from the ground to the pan itself. So this one actually has a connection for both the input and the output to the pan. So I'm going to maybe make a little, I mean there's nothing otherwise wrong with the tank, but it is riveted and that's a bit of a pain in the ass. I'd like to just replace the tank considering this probably isn't stock anyway. But we could drill these rivets out and put a little washer in there made out of, like, I don't know, a blister pack or something. Just some mylar, just to isolate it, and then just use screws to reconnect it. There's a possibility. We could use maybe one of those heat sink collars that you use on semiconductors when they're insulated from the screw. We could just elevate it with that. Could have a little gap there, no biggie. As long as it's not touching, there is a fair bit of room around it on that side, so that might work as well. Alright, so that one's just spinning in the hole. I'll have to do something else with that. Alright, that worked rather well. Sometimes you get a win, eh? So these are just the screw insulators that you find on heat sinks to suit a M3 screw. That has spaced the shield off the pan, so now this is fully isolated from the pan, so that should fix our hum issues. And from the outside it looks pretty much the same, just with 2 screws where the rivets once were. Now this is where the time gets eaten up on jobs like this. Just little bits and pieces that require, you know, creative thinking. Could have just replaced the tank, would have cost, you know, 70, 80 bucks. But now we're able to keep that part, which sounds fantastic by the way, but that will make it perform as good as it can. And that sort of brings me to these resto jobs. There's so many little, it's death by 1,000 cuts. Eventually you end up with a fantastic sounding amplifier, but there's like 50, 60 things that need addressing. I've got no idea how these other guys manage to collect their bills once they give back an amplifier that is humming or has hiss or crackling. Obviously they don't stay customers for long because they end up here, but these guys still collect the money and give an absolutely substandard result. Like, if I power up an amplifier here when the customer's here to pick it up and there is any issue at all, the customer hones in on that like a hawk, and they're like, oh, why does it do that? Can we stop it doing that? It shouldn't do that, should it? I don't know how these other guys manage to convince the customer to hand over the cash and walk out with the amplifier when there's still issues. Maybe that's why they own houses and I don't. Right, so here's the new Reverb cables. They look the same length, but they're not. They're slightly different. These are the Switchcraft right angle connectors I was discussing. They are fantastic, and these cables will last forever. So I think I might sell these ready-made on my website to retrofit vintage amps, because that's often, if you've got oscillations, that kind of thing, that can be caused by the reverb return cable starting to fail. And as you saw there, these cables are really shitty at the best of times. If they're not so corroded that you can't solder to them, the ends are breaking, cracked and everything like we showed in the last video, and then people just put big dollops of solder on there to try and fix it, but that doesn't really work. And the center insulation on these is really sensitive to heat, so you know, you heat it up enough to solder and then it melts the center insulation, so it's a really uphill fight with the stock cables. Yeah, they look original and everything, but I prefer my amps to actually work rather than be all original. Call me crazy, I know. So I might sell a Princeton reverb set and then the slightly longer set for deluxe reverb. You don't really want excess cable bunched up either. You sort of want it to go right to the point with the minimum amount of slack. So if you're after a new set of upgraded cables, have a look on the website. I'll list them as soon as they're ready. And that is the Canare, I think that's how you say it, GS6, which is my favourite instrument cable. Likewise on the foot switch, I've replaced them as well. Being right angle, you can sit the amp on its back now in the car and whatever, and they'll clear the back of the cabinet so they won't get injured. So I'll clean up the soldering on the inside of this thing. Next thing we'll do is just cut a little piece of plastic or something for the base, and then just use some duct tape, some electrical tape to sort of stretch around it and hold it in place. I've got some new foot switches on the way, but this will be functionally fine. Man, I really hate the wire that Fender made these pedals out of. That's shorted. It's disconnected at both ends. And somewhere in the line it is shorted. And it's normally right where you solder it, because the heat melts this insulation really easily. It's like the most cheap, crappy wire in existence. But I've peeled that back a bit, so we're going to have to take another foot off. Probably have to re-terminate the whole body. This is why you don't fix foot pedals, you just replace them. But yeah. Well, found our short. You can see down in there the insulation just totally stops. So we're going to have to cut back. Yeah, see that? Going to have to cut back beyond that point and inspect the cable. So that's broken the insulation where the cable gland was putting mechanical pressure on it. Horrible cable, this stuff. Alright, champions, just a quick look at how I like to do my speaker cables. This is the Switchcraft plug to replace the corroded factory one, and some PVC wiring there to replace the cloth stuff, which is going all mouldy. You can see here I've heat shrunk it, but I've also added another little layer there. You can see just where the crimp, the sort of strain relieving crimps are. So when you fold them over, there's just less of a chance of you breaking that primary insulation. You don't need to tighten hell out of them, just nip it up a little bit, and that's more than adequate. Then at the other end I just put a little I don't know, 1/2 inch, 3/4 inch piece just to keep the wrap nice and tight. Alright champions, what do we do? So full recap, a few voicing changes along the way. which I'll get into in a members only video. We've got, as you can see there, the new filter cap bank, which I've mounted. I'll go into that shortly. New transformer, hardwired for 240 volts. Got some backup diodes there on the rectifier. Just someone commented, I think there's a fundamental misunderstanding of what these do. These are not in parallel with the rectifier. They are in series with the rectifier plates. So they'll only drop, yeah, like 0.5, 0.6 of a volt, whatever they are, their forward voltage drop. But the rectifier is still in circuit, so you still get the voltage drop from the rectifier valve. So they basically just share the voltage, the peak inverse voltage, with the rectifier valve. So that makes life easier on the rectifier valve. And if it was even then to go short for whatever reason, shock or just an old valve, they kick in and do the entire job, which they're more than capable of doing, and that protects the capacitors from receiving AC from an unrectified, B+, that would otherwise make them explode. So what does that mean in practice? If you're playing a gig and the rectifier went short, you'd probably notice a slight increase in headroom as the voltages across the amp increase by whatever the voltage drop of the rectifier valve you've chosen used to be. The bias point will then rise because you've got a higher plate voltage, but I've biased this pretty cool at 50% anyway, because that's more optimal for the tremolo. So if it were to go short, you could still finish the gig and just deal with it later. It's basically just an insurance policy. If the rectifier valve ever does go short, which it's less likely to now because its life is easier because it's got half the peak inverse voltage across it, no further damage would occur. Alright, we've got our same lead. I've just shortened it and re-terminated the inside, and we've got our soldered ground connection on the inside there with about half a foot of excess earth wire. So if the cord ever did get pulled out, these ends, which don't have much slack, the neutral and the active, would get pulled off their terminals, and the ground would be the last thing to be connected. So I've rewired the mains to go from the active to the fuse tip, from the fuse ring to the power switch, from the power switch, I know it's a blue cable, but that's just the color coding of the Hammond transformer primary. Then it goes from the other side of the transformer and primary, just directly connected to neutral via that unused terminal on the what was previously a ground switch. We've chucked in some screen grids down there just to protect the output valves. They are run above spec in this amp at about 410 volts ish. So that just gives the screen grids a fighting chance. So here's the star of the show, our little cap board. I've just used a tag board and removed the tags from one side, filed a little bit off it so it's got clearance to the bell housing there, and then mounted the caps on the other row of terminals. There was conveniently a row of holes underneath the caps as well, so I've just used them to secure them with cable ties. You could use silicone as well. But what I think I'll do is I'll make a little universal board that, like a PCB, where these can stand up, because there's plenty of room in there. You can get, if it was down a little bit lower, you can get these caps standing up. That's not a problem, but even still, you could lean them over. And just have the hole set for this center, and it would be like a universal recapping board to use modern caps in the old Fenders, without having to rely on the somewhat unreliable other can cap choices. Now, someone else did ask about the Mojo Tone or the JJ's multi-section cap. Problem is with them is they're a larger diameter of the terminals. You've got to actually drill that hole out with the hole saw to, like, I forget the size, it's like 40 mil or something ridiculous, and it's quite a traumatic experience, and I don't want to go drilling holes in a 65 Princeton Reverb amp. So this didn't require any permanent modifications to the amp at all. This could be reversed if someone did want to go with a can cap in the future for a more authentic looking internal, but just play the bloody thing, eh? And hidden down there we've got two little fusible resistors, 100 ohm. That's just going to the cathode, which is also ground on one of the power valve sockets, and that is our artificial center tap for the heaters. So we've got a customary box of shame. Again, it doesn't look like a hell of a lot, but a lot of hours went into this thing, and it should be solid as a rock for many, many, many years to come. How many? Many, many. Look at those beautiful Switchcraft plugs. They really look like they mean business, eh? Professional. So just a quick look at the input jacks. That one's still good. That's your input one. You can see there it's making contact reliably. Probably needs a little bit of a retension, so I might look at that one as well, but we'll look at retensioning this little bugger, because it's not even touching there when it's not plugged in. You can see there's a bend there in it from someone else trying to bend it. So I'll put a plug in, then I get a flat blade screwdriver and I bend it at the root of the contact, and that actually sometimes works. In this case it looks like it has. Only just. I might need to just do it again, but I've got to put the camera down first. Yeah, that's sorted it now. You can see there's a bit of movement there as it closes. So I'll give them a little bit of a clean as well, and we'll be able to get away with reusing that jack. Alright, so nothing left to do now except take a few measurements for the report and get this bugger back into the cabinet, do some quick sound samples and move on to the next one. Alright, so just about to put the chassis back in, and just thought I'd nip up these screws, but they're just pulling out. The shitty chipboard is done. She's not really suited for this purpose. So I'll put some threaded inserts in, like little anchors, and that we'll have to replace them with some machine screws in that case. It's either that or replace the whole baffle, refabric it. Yeah, massive job. That would be another several $100 to sort out, on top of the already pretty large bill that this thing's added up to. Well, we've got the baffle out. May as well inspect the speaker. It's looking good, sounding good, but we'll just clean the dust and stuff off it to make sure there's no strange noises from stuff rattling against the surround. Cabinet looks funny with no front or back on it, doesn't it? Alright, so here's the threaded inserts, otherwise known as demon nuts. They're like a steel coarse thread on the outside, really anchors into the wheat bix this stuff becomes, and then it's got a machine thread on the inside, in this case M4, and we can use a machine screw to fix it in place. So we can hang on to the stock baffle and not have to make a new one out of ply and try and reuse the grill cloth, and yeah. You can see here that someone's just snapped off the original screw patterns because they've wanted to fit a 4-screw Celestian on there. That's one way of doing it, I guess. There we go, one baffle. Stronger than it ever has been. Good stuff. Alright, so if you recall from the first episode, one of the strap screws was severely reamed out. As luck would have it, I've got some old stock, and we've got a replacement screw we can use for that. I had a customer once that just wanted his amp to look brand new. I think it was a Silverface twin or something. So we just replaced all the hardware and made it look schmick again for him. I asked him if he wanted the old stuff returned. He said, "No, don't worry about it. Just hang on to it or throw it out." So it's handy when you hang on to some old stuff so you can match the look of some completely destroyed stuff.